All right, welcome back. My name is Christopher Ogume. As you are familiar already, you are welcome to the Chemistry Mastery Academy. Now, we are looking at a new topic today, and the topic is salts. We're looking at salt. Now, what is a salt? A salt is referred to as the compound formed when all or part of the ionizable hydrogen ion in an acid is replaced by a metallic or ammonium ion. Basically, what this is saying is this. It's pretty simple. A salt is actually a substance that is formed when the hydrogen ion in an acid goes away and a metal or an ammonium ion takes its place. That's what a salt is. So it means that a salt is a substance that has a metallic ion or an ammonium ion taking the place of the hydrogen ion. Exactly. So it means that I take an acid. Now, in this acid, we have hydrogen ion and we have another ion. Now, in this acid, when I remove the hydrogen ion, of course, we know the law of conservation of mass says that energy can neither be created nor destroyed, but can be transformed from one form to another, right? So when I remove the hydrogen ion, there will be need for what? Replacement. So in place of the hydrogen ion that I have removed, by the time I put a metallic ion or an ammonium ion, I would have succeeded in forming what? A salt. Okay, so let's look at a chemical equation to actually show this. So for example now, we have HCl. Now, this is hydrochloric acid, right? Now, if you check this hydrochloric acid, we have hydrogen, we have chlorine. If I remove this hydrogen that is here, and replace it with a metal or an ammonium, this substance will now change to a salt. So look at this, HCl plus NaOH, sodium hydroxide. Now, when I react these two, this hydrogen will go off, and this sodium will now take its place. So we have sodium taking the place of what? Hydrogen. And hydrogen attaching itself to what? This OH. Okay? So sodium will take the place of hydrogen. So hydrogen is out, remaining Cl. We now have sodium what? Chloride. This sodium chloride that has been formed is what we call a salt. Is that clear? So you see that the hydrogen that was with chlorine have been replaced by what? Sodium, forming what? A salt. All right. So now, sometimes it is not all of the hydrogen that goes off. Sometimes it's only part of the what? Hydrogen. Now, for this one, that all of the hydrogen goes off, this salt that is formed is called a normal salt. So a normal salt is the salt that all of the hydrogen ion in the acid is replaced by a metallic ion or an ammonium ion. Okay, that's a normal salt. Then we have another kind of reaction whereby all of the hydrogen ion is not replaced. For example, let's see H2SO4 plus potassium hydroxide. Plus what? Potassium hydroxide. Now, in this case, please, our focus is on salt now. I could have written the full, products where there's water, but I don't want to do that. I'm just trying to narrow our attention to this salt, which is the topic we're discussing. Now, H2SO4 plus potassium hydroxide, when they react, what happens? Remember, a salt is formed when the hydrogen ion is replaced by what? A metallic or ammonium ion. Now, we have hydrogen ion here. Now, in this potassium hydroxide, which one is metal here? Potassium is the metal here. Why is it a metal? It is a metal because it can easily donate electron. For example, potassium is 19. We have 2 in the first share 8 in the second share, and we have 9 in the outermost share. Now, sorry, we have 2 in the first share, 8 in the second share, 8 in the third share, and we have 1 in the outermost share. It can easily give out that 1 in this outermost share so that it can be balanced. So it's a metal. Therefore, it is K that will come to replace what? Hydrogen here. But it cannot replace all of the hydrogen. Why? Because hydrogen, how many electrons does it have? Only 1. Is it not so? And it needs 1 to complete it. Is it not so? If K that is giving out 1 gives 1 to hydrogen, hydrogen will be balanced, right? K will be balanced. But it is not only 1 hydrogen that is here. We have 2 hydrogen. So once K take 1 of the hydrogen, there's still 1 hydrogen what remaining. Is it not so? So what we now have is KHSO4. Is that clear? KHSO4. Remember, it is 2 hydrogen that we have here, right? So this K took the place of 1 of the hydrogen, leaving behind the remaining 1 hydrogen that it could not react with. It's not so. So we have KHSO4. Now this is a salt. KHSO4 is a salt, but it is not a normal salt. Because of the presence of hydrogen in the salt, it is called acidic salt. So an acidic salt is a salt that is formed when only part of the hydrogen ion in the acid is replaced. Is that clear? From the illustration that we have on the board. Okay? So, moving further. So, we said we have normal salt. Now, types of salts. There are 5 main types of salts. We have normal salt, we have acid salt, we have basic salt, we have double salt, we have what? Complex salts. Okay? So, we have talked about normal salt. We have talked about acid salt. Now, let's talk about basic salt. We have talked about normal, acid. Now, let's talk about basic salt. Now, for basic salts, we say basic salts are formed when only part of the hydroxide ions of a base are replaced by the negative ions from an acid. So, in basic salts, the base is only some part of that hydroxide in the base that is replaced. That's what forms a basic salt. Okay, so we have ZNOH. This is an hydroxide, is it not? Yeah. So this is a base, is not because of the presence of what? Hydroxide. But if you check, how many hydroxides do we have here? This 2 here is telling us that we have 2 hydroxides. Okay? So now, plus HCl. Now let's see. So ZN to what? This one. Okay? But now, it is not all of these that will go. So we now have OHCl. Okay? Like we have here. So it is not all of these that went off. It's only part of it. Now, this compound that is formed is a salt. But it's not a normal salt. It's not an acidic salt, but a basic salt. It is a basic salt because of the presence of this what? Hydroxide. So all of the hydroxide we are not giving off. Okay? Some were still remaining. So it forms what? A basic salt. Now the next type of salt we have is double salts. Now, double salts is the type of salt that have 2 metallic ions. 2 what? Metallic ions. 2 metallic ions. So look at this. In this normal salt now, how many metallic ions do we have? We have only 1, which is what? Sodium. In this one, how many metallic ions do we have? We have 1, which is what? Potassium. In this one, how many metallic ions do we have? We have 1, which is what? Zinc. But in double salt, we have 2 metallic ions. So let's see. From what we have on the board, A double salt is alright. Now let's look at double salts. Sorry for that break in transmission. Just had a little issue. So now let's look at double salts. Now we say double salts are salts which ionize to produce three different types of ions in solution. So in double salt, let's look at this. Normal salt, we have only one ion, metallic ion. In acidic salt, we have one metallic ion. In basic salt, we have one metallic ion, right? Now, in double salt, we have two metallic ion that are positive, and we have another ion that is what? Negative. So we have two positive ion and one negative ion. An example is ammonium ion 2 tetra ortho sulfate 6 ether hydrate. So look at this. How many ion do we have? We have ammonium ion, we have ion, both of them are positive, and we have what? Sulfate, also sulfate rather, that's SO4. This one is not negative. So we have this as ammonium NH4 Fe ion, and we have SO4, then 6H2 ether 6 hydrate water H2O. This is double salt. Is that clear? Alright, so let's move further. Then we have complex salt. Now, complex salt, as we have here, complex salt contains complex ion. That is, ion consisting of charged group of what? Atom. Charged group of what? Atom. So look at this. This is a complex salt. This is a complex salt. So charged group of what? Atom. This is a charged group. This is another charged group. This is another what? Charged group. This is a complex salt. Okay? Now, next off, we have hydrolysis of salt. Hydrolysis of salt. Now, what is hydrolysis of salt? Hydrolysis of salt is simply turning salt back to the acid and the base that what formed it. That's hydrolysis of salt. Okay, so let's look at this equation on the board. We have Na2CO3. This is a salt. Okay, this salt is formed when you mix sodium hydroxide and H2CO3. Okay, now when you take the salt and mix it with water, it will now form the acid and the base that what originally came together to form the salt. So now look at this now. When you take this salt and mix it with water, you give you what? Sodium hydroxide and what? H2CO3. So hydrolysis of salt is simply the process of changing the salt back to the original reactants, which are the acid and the base that formed it. Okay? So it's more like a reversible what? Process. So another way you can also put it is this. Hydrolysis of salt is adding water to salt so as to change it to what? The original acid and what? Alkali responsible for its formation. Okay. Now let's look at the uses of salt. Ammonium salt is used as what? Electrolyte in dry cell. So in your battery, ammonium salt is used, okay, as an electrolyte. Then we have calcium carbonate is used as what? Medicine to neutralize acidity in the what? Stomach. You know, remember Andrew liver salt now? So your Andrew liver salt is what you actually take to stop that burning sensation that you feel inside your stomach, right? Good. So that's why we said calcium carbonate is used as medicine to neutralize acidity in the stomach. Then we have calcium chloride is used as what? Antifreeze. Is used as what? Antifreeze. You know, when you travel abroad and during winter, you have ice all over the place, right? Ice covers the road. So what they actually do to take off those ice or snow from the road so that cars can actually move, they use what we call antifreeze. Now, what is antifreeze? Antifreeze actually what makes the what ice to melt faster. So we have calcium chloride is used as antifreeze, while fused calcium chloride is used as a drying agent and also in desiccator. Then we have calcium tetrazosulfate sulfate 6 is used for making plaster of Paris. What is plaster of Paris? Your POP. So it's calcium sulfate that they use to make your what? Your POP. Then we have copper sulfate is used in dyeing and calico printing. All right. Now, what are the methods of preparing what? Salts. Of course, we have already established that neutralization reaction is the process of mixing acid and base to get salt. So one of the ways of preparing salt is what? Neutralization of an acid by an alkali. Then we have action of dilute acid on a metal. So when you take dilute acid and you bring a metal together with it, it will form salt. Then action of dilute acid on an insoluble what? Base. So when you take a base that does not dissolve in water and then you mix it with what? Acid, you will form a salt. Then action of dilute acid on triazocarbonate what? 4. That is when you take CaCO, when you take triazocarbonate 4, that is H2CO3, and then you mix it with acid, you will get a salt. Then we have double decomposition or precipitation. Double decomposition or precipitation. That will also give us what? Salt. Then we have direct combination of two elements. So, for example, now we have sodium chloride. So if I take sodium and I take chlorine, I join them together, I will form a salt. That's what I mean by direct combination of what? Two elements. Now, let's look at these terms: efflorescence, deliquescence, and hygroscopic. Now, efflorescence are substances which, on exposure to air, lose some or all of their water of crystallization. So the phenomenon or process is what? Efflorescence. There is loss of weight or mass of the substance. Now listen, this is what it means. No need for this plenty talk. Now, for efflorescence, when you expose it, okay, an efflorescent is a substance that when you expose it, some of it will be lost to the atmosphere. Yes, some of it will be lost to the atmosphere. Example, your camphor. So when you take camphor and you expose it, what happens? It will be reducing in size, right? As a result of the fact that some of it has what been lost to the atmosphere. So a camphor is an efflorescence what? Substance. Then deliquescence. Deliquescence are substances that absorb so much water from air and form what? Solution. Now deliquescence is different from efflorescence. Now efflorescence, we said, will lose part of itself, right? But in deliquescence, deliquescence will what? Collect from the environment. Okay? What does it collect from the environment? It collects the water from the what? Environment. And as it collects the water from the environment, it will now dissolve in the water. Are you getting it now? So, deliquescent substances collect from the environment, efflorescent substances give to the environment. Then we have hygroscopic. Now, hygroscopic substances are substances which absorb moisture on exposure to the atmosphere without forming a solution. Now, hygroscopic wants to look like deliquescent, but it's not like it. While deliquescent will absorb water and dissolve in it, hygroscopic will absorb water but will not dissolve in it. Okay, so the major difference between deliquescent and hygroscopic is that deliquescent will dissolve in the water that it absorbs, hygroscopic does not dissolve in the water that it absorbs from the environment. Okay, All right, that brings us to the end of our class on salt. In our next class, we'll be looking at carbon and its properties. Carbon and its properties. So I'll see you in our next class. Thank you for staying with us till this time. Do well to subscribe to our channel so that you can always get updates on latest videos that we are dropping. Thank you very much. Thank you very much. Thank you very much.